Hello students, this is Pallav sir. I welcome you all in my class. So today our topic is how to find out the zeros of the following polynomial and also how to verify the relationship between the zeros and the coefficients. Fine, so let's start. I have two examples for you all. 5x squared minus 8x minus 4 and x squared minus 5. So we'll solve it individually. Okay. Now let's start with question number A. The first thing that we'll do is we'll find out the coefficients. Fine. Now as we know, the general form of quadratic equation is ax squared plus bx plus c, isn't it? Now this is also a polynomial. So if I write in this way, suppose if I rub it. Now suppose if I write it in this way, p of x is equals to 5x squared minus 8x minus 4. Now compare this polynomial with the general form. Fine, so what you see is that in place of a, which number we will find? It is 5. In place of b, which number is there? It is minus 8. And in place of c, which number is there? It is minus 4. So these are the coefficients. This is the first thing that you have to do. Okay, now the next thing is, as because you have to verify the relationship between the zeros and the coefficients. So coefficients we are already aware of. Fine. Now we are not aware of what are the zeros. Fine. So now we'll find out the zeros, and to get the zeros we'll use middle term factorization method. Fine. So let's start, students. So we'll write the polynomial 5x squared minus 8x minus 4. Now what is the first step that we do? We find the product. So product is 4 and plus minus is, that is the difference of the two numbers will be 8. So that is, what is the product? 5 into 4 is 20 and the difference should be 8. And the difference should be 8. So which are the two numbers? When you multiply, you will get 20 and the difference between the two numbers would be 8. Now that would be 10 into 2. So 10 2s are 20, and if you put 10 and 2 here, it also satisfies this criteria as well. So the required two number is 10 and 2. So we'll write it down. That is 10 minus 2 x minus 4. Now open the bracket. That is 5x squared minus 10 into x, 10x, minus into minus, plus 2 into x, 2x, minus 4. Now what is the next thing that we'll do? Yes, we'll take the common from first two term and the last two term. Fine. So what is the common? Common is 5 and x, isn't it? So inside the bracket there will be x minus 2. Now from with this 2, what would be the common part? 2. So x minus 2. Now as you see, these two are matching. So we are already on the right path. So now what is the next step then? Now x minus 2 is a common form to both the terms. So we'll take x minus 2 as common. And the rest part would be x plus 2. Now we'll get the zeros, as we have already discussed this in our previous class, isn't it? So what is it? X minus 2. So we'll compare x minus 2 with 0. And what is the next part? 5x plus 2. 5x plus 2 is equals to 0. Now if we transpose this minus 2 towards this side, we'll get x is equals to 2. Fine. And this is the first value of x. Now let us find out the second value of x. For that we need to transpose this plus 2 towards this side. So we'll get x, 5x is equals to minus 2 and x will be minus 2 by 5. Fine. Now what is the value of alpha? As you know that what are the two zeros of the quadratic polynomial? Alpha and beta, isn't it? So what is alpha? We'll consider alpha as 2 and beta as minus 2 by 5. So these are the zeros, students. These are the zeros. And what are the coefficients? So these are the zeros. Okay, and what are the coefficient? A, B and C. So A was 5 minus 8, 4. 5 minus 8 and 4. So these are the coefficients. So these are the coefficients of the given polynomial. Coefficients. Okay, now what we'll do is that now we'll do the verification of what is the question given? Verify the relationship between the zeros and the coefficients. So there are two relations as we have already discussed in our previous class. So the first relation, our first relation is alpha plus beta should be equals to minus b by a. Okay, so I'm not going with the verification, you just have to remember the two relations. That is, the first relation is alpha plus beta is equals to minus b by a. So this is LHS, students. So individually we have to show, and this is RHS. Okay, so we need to prove that the value of LHS should match with RHS. So let's do individually first. LHS is alpha plus beta. Now we are going to substitute the value of alpha. Alpha is 2. Now plus is already there in the expression. Now beta is what? Minus 2 by 5. Minus 2 by 5. So we'll put it inside the bracket. Now we'll open the bracket. Plus minus would be minus. Okay, now 2 is carrying 1 as a denominator. We'll take LCM 5. So this would be 10 minus 2. So your answer would be 8 upon 5. Okay, I hope all of you have understood. Now let's check the RHS answer. So RHS is what? Minus b by a, isn't it? So minus sign is already there in the expression. We'll write minus. Now we'll see what is the value of b. B is minus 8. So we'll write minus 8. And what is a? A is 5. So minus minus will become plus. So RHS value is what? 8 by 5. So see, both the values of LHS and RHS is similar, not missing. So therefore LHS is equals to RHS. So hence we have proved the first relation. Fine. Now let's move on to the second relation now. Second relation is what? Alpha into beta should be equals to c by a. That is, the product of zeros should be equals to c by a. Same thing we have to do. We have to again show the value of LHS should match with the value of RHS. So now first of all we do LHS, and here we'll do RHS. So RHS is c by a, and this is alpha into beta. Okay. Now, what is alpha? Alpha is 2 and beta is minus 2 by 5. Alpha is 2 and beta is minus 2 by 5. So we cannot reduce, we'll just directly multiply the numerator with numerator and denominator with denominator. So in that way we'll get minus 4 by 5. Now let's see what is the value of c given. C is 4. C is 4. And what is a given? 5. Now we are in trouble. So here we are getting minus beta is minus 2 by 5. Okay, I've written the value of c wrong. That is, it would be minus 4. Sorry. Now what we'll do is that we'll write value of c as minus 4. Now in this way the value of LHS would be equals to RHS. So verified. So this is what you have to do if a question comes like this. This is a very important question, and this type of question will carry 3 marks to test. Fine. So let us see how to solve the second question. Number B. So here we have only 2 terms, isn't it? So just a minute. So the polynomial p of x is equals to x square minus 5. Now there is no x term. Fine. So if we compare this with the general form of quadratic equation, that is ax square plus bx plus c, what would be the value of a? Value of a would be 1. As there is no x term present, so value of b would be equals to 0. And what would be the value of c, students? It would be minus 5. Okay, so these are the coefficients. Now to get the zeros we have to go for middle term factorization. But as you see, this polynomial is only having two terms, so middle term factorization method will not be applied here. Now what to do? Now for this type of sum, what you have to do is that x square minus root 5 whole square. Now as you see, 5 can be written as root 5 whole squares. As you know that root 5 square means root 5 into root 5, and root 5 into root 5 is what? Root 25, and we know that what is the square root value of 25? It is 5. So in place of 5, obviously we can write root 5 whole square. Now as we have written this form, this thing is obeying one identity. Which identity? A square minus b square. And what is the formula? A plus b and a minus b, isn't it? So this is the identity that will apply here. Okay, now in place of a, what we are having? In place of a we are having x, and in place of b there is root 5. So let us apply the formula here. So x square minus root 5 whole square would be a plus b, that is x plus root 5, and a minus b, so that would be x minus root 5. Now from here what we have to do? We have to compare this two terms with 0, isn't it? To get the 0, isn't it? So x plus root 5 is equals to 0, and x minus root 5 would be also equals to 0. So in first case we'll get minus root 5, and in another case we'll get positive root 5. So value of alpha is what? Value of alpha will consider as minus root 5, and beta would be positive root 5. Okay, so these are the zeros, and what are the coefficients we have? A equals to minus 1, b equals to 0, and c is equals to minus 5. Now let us verify the relation. Now what is the first relation we are having? The first relation is now the first relation is sum of the zeros would be equals to minus b by a. So this is alpha plus beta. What is alpha we are having? Minus root 5, and beta minus root 5, and beta is positive root 5. So answer is 0. Okay. Now what is minus b by a? So minus sign is already there in the expression. So what is b? B is 0. B is 0 and a is 1. So answer would be also 0. So therefore LHS is equals to RHS. Verified, isn't it? Now let's move on to the second relation. Second relation is product of the zeros. Product of the zeros is equals to C by A. Fine. So now LHS would be equals to RHS. This is what we have to prove. Very simple. So minus root 5 into positive root 5. That will give you the answer as what? Minus root 25. And what is 25 root 25? Root 25 is 5. So the answer of LHS is minus 5. And what is RHS? RHS is C by A. So what is the value of C, students? Value of C is minus 5 and A is 1. So minus 5 upon 1. So that will also give you minus 5. So therefore LHS is equals to RHS. Verified. Okay, I hope all of you have understood this two sums very properly. So that's it for today's session. So I will be giving you some worksheet. So do solve it and submit it in the WhatsApp group. Okay, thank you so much. God bless you all and take care.